Hello and welcome to this video when we look at the volume of revolution of area enclosed by two curves rotated through 360 degrees about the y-axis. When we revolve this shaded area about the y-axis, what kind of solid will we get? From the previous lectures, you should have an idea that we need to consider the difference of two volumes. Firstly, we will look at the bigger volume generated by the outer curve. So we will have this kind of volume, this bowl-shaped structure that's generated when we revolve x1 about the y-axis. We can consider the volume formed as a sum of horizontal circular discs with very thin change in y, with very small change in y as its small thickness. For each of these that we add up, whose volume we add up, the radius is x1. Therefore, the volume generated when we revolve the area between the y-axis and the outer curve about the y-axis will be integration from c to d pi r square. Now the r here is x1, so pi r square dy. So this is volume of the bigger solid. So let's consider the smaller solid which forms the hollow part in the middle. We know that when we revolve x2 equals to g2y about the y-axis, we will generate the hollow solid in the center, and we need to subtract this volume out from the volume of the bigger solid we have found earlier. Let me explain again with a clearer diagram. When we revolve the inner curve x2 equals to g2y about the y-axis, we will end up with a volume like this. So what I mean is, if I revolve this red shaded region about the y-axis, it will generate this solid. So how do we get the volume of this solid that I have outlined in red? We know from previous lecture that we can consider it as a sum of horizontal circular discs like that, with the radius as the magnitude of x2, the x coordinate of each point. So the volume of the smaller inner solid will be integration from c to d pi r square, where the radius is x2 dy. Finally, we know that the volume that we want, which is the volume generated by this gray shaded area, will need to be the difference between the bigger solid and the second and the smaller solid, and that gives us this expression here. Thank you for watching this video.